So if you can remember, in the last class, we have discussed about the cloud services, and they're basically about the three service models of cloud services we have discussed. So in the infrastructure as a service, platform as a service, software as a service, we have discussed. Apart from that, we have discussed about the different apart from cloud computing, we have other two mainly computing methods, which are fog computing and edge computing. So in there, actually, we discussed about how edge computing is done in the local area network and how a local server is used to do the computing related to the data that is received from the local network. And then we discussed about how fog computing is used in a situation where we want to do processing without sending the data to the cloud server. So if you want to do the computing very fast, and if the resources are lacking in the edge or the edge of the network, then we can upload the data to a nearby fog server, which is able to do computation more than the edge computer. And then we will be able to do the processing at the fog server. So fog computing is an intermediate computing method that lies between the edge computing and the cloud computing, that enables us to do the computations and do the necessary work in a less delay, with a less delay, and with high processing efficiency. So this fog computing also has the capabilities similar to cloud computer. Sometimes it might have a lower processing power and a lower, storage facilities, or storage space allocated for data storage. Fog computing is also anyway like an alternative solution for cloud computing. So those are the things we, I think, discussed in the last class. Also, at the end, we discussed about something called the multi-access edge computing method. So multi-access edge computing method is basically about using mobile telecommunication networks systems to do the multi-access edge computing technology. That means we allow multiple devices which are of different types to connect to the edge network uh, through the cellular communication, through the radio cellular communication. So in the multi-access edge computing means like different devices can access using the cellular mobile telecommunication systems. So that is basically the idea of multi-access edge computing. Basically, the advantages of that communication will be that the latency will be maintained at a low level, which is about below 10 milliseconds. Also, even if the devices move, even if there's some mobility in the devices, the network is still able to capture the data and receive the data reliably, such that the data is not lost, and also the data will get processed at the edge server or at the cloud server based on the requirement at that specific location and at that specific application. The computing location might differ. So in here, actually, in the multi-access edge computing, real-time updates can be given to the IoT devices who are connected to the local network, so that the devices who are connected will get real-time information about the local network. So real-time means like without much delay. So exactly as if you are sending the data and you just receiving within very like milliseconds of delay. So within milliseconds, you are receiving a feedback from the network, servers, the servers who are giving a feedback. So you are receiving a feedback from the servers within milliseconds of delay, which means that it is a real-time feedback system. And then we also have high data rates available with this uh, cellular communication assisted multi-access edge computing method, mainly because cellular communication technologies have evolved over the years, and its capabilities are like at a good point, which enables the communication to have high data rates. So when you compare with the other wireless communication technologies, like even Bluetooth, LoRa, and Zigbee, they don't have the data rates that the cellular communication has. So cellular communication has the ability to give high data rates while also give that communication up to a higher communication radius. So many users in a radius of about 1 kilometer, 1.5 kilometer can access the network infrastructure, which is basically you can access the base station, telecommunication tower, which is nearest to your device. So we discussed up to multi-access edge computing in the last class. So up to that point, we have discussed and we have sort of concluded the section on cloud computing, fog computing, and edge computing. So any questions on that? There's one question about physically demonstrating the project tomorrow. Actually, tomorrow we don't have IoT class, right? So you don't need to come and physically demonstrate the project. Okay, so it's okay that you don't have to come tomorrow. So in this week, in the IoT interactive class, if you are able, it's good if you can come and demonstrate the project during this week in the Friday IoT interactive class from 2 to 4. If you can come, you can come. Otherwise, like, you can demonstrate everything in your video and you submit it. By observing the video, I will give a mark. So it's better if you come and present yourself at the interactive class and explain to me what's going on. Is it okay with you? Are you here, Kalindu? Shall I move ahead? So industrial IoT systems. So industrial IoT is the next section we are going to discuss about. So in there actually um there are like many differences that we have to observe when we compare with the normal conventional IoT networks and IoT systems. So first and foremost, when we look at industrial IoT systems, we can see there's a change in the size and the scale of sensors that are used for industrial IoT than the normal IoT systems. So the size of the sensors are considerably large. So if you consider the sensors that are given in these figures, you can see that for temperature measurements, we have this big sensor which is used, and it is very robust and not that like weak uh, when we have like different temperature, high temperature conditions, high pressure conditions in the environment. These sensors are very robust, such that they are able to withstand all these different challenging environments, right? So because of that, industrial environments, sensors are designed to withstand these, very challenging environments. So because of that, these sensors are built with high, uh, very strong, durable and robust materials, and then they are used for a very long time in these manufacturing facilities. So the size and shape and the different models used for these industrial systems and facilities is different from the normal IoT, uh, normal IoT systems. So the difference is basically that these industrial IoT systems are more robust. These sensors, processors are more robust, and they can withstand more challenging environments than the conventional IoT sensors and machines and processors. So the normal IoT systems are consumer centric, while these industrial ones are more robust and can face different worst case scenarios. So industrial IoT systems have these kind of sensors, and their properties and features are kind of considerably different from the normal IoT systems, and they are used for different, applications, such as like these sensors are used for manufacturing, in manufacturing facilities, in manufacturing factories, then for logistics and providing logistic services, and then for healthcare and so on. So these are some of the application areas where you can see IIoT being applied. Also, when you compare with the embedded systems also are different in the IIoT systems, which are like Arduino systems, are also Arduino embedded, controller systems are also more robust than the normal Arduino one. And then also you have some, integrated PLCs, which are used with Arduino, which means that PLCs are the processing units that are basically used in the manufacturing facilities. So when you consider these Arduino based PLCs, the PLCs have integrated with the Arduino to do more functions than the PLCs normally doing. So Arduino also provides some value to the PLC, and Arduino has more libraries and more functions that it can do. So sometimes that PLC is enhanced when you are using this Arduino. So these are some of the products that are available for the in the market for the manufacturing facilities. Another one is this Raspberry Pi based user interface. So Raspberry Pi and its like performances are embedded in this user interface, so that the user can get efficient output from the user interface, and also it can do some more computation than the normal user interface with standard processing ability. So the sensors are connected to uh, I mean, if we are considering the Internet of Things, then the sensors are connected to the PLC, right? So the sensors which are collecting measurements of the environment in the manufacturing facilities are sent. The data from those sensors are connected to the PLC first, and then the PLC is then connected to the routers or switches, which will be connected to the internet. There will also be like a local server which will collect the information from the PLCs and do the local computation there. So the PLC will be connected to the local server, local point where the local computation are done. And also this, data can be also forwarded to the access point through wired or wireless connection. And then that data can be forwarded to the cloud servers where the data can be centralized, stored in a centralized manner. So that would be about the IIoT setup, hardware setup, how the sensors are connected to the processing unit, and then how the processing unit uploads the data to the local server and also to the local access point. After that, the local access point will forward the data to the like a centralized cloud server, which will store all the data in it. So, with regard to the IIoT, we will discuss about the network architecture. And then we will discuss about how we can, how we can compare the industrial IIoT systems with, how we can compare the different standards of industrial IIoT systems or industrial, standards with the uh, industrial standards that are available, which are basically like Industrial 3.0, Industrial 4.0, and likewise. So we will discuss about that next. So there's another message. So if you are not able to present this week Friday, then you can present next week Friday. Okay. I think next week Friday is the last date of the lectures. So you can present either this week Friday or next week Friday. I will allow that. So that would be the last date. It would be okay for you, right? Is it okay? So I will move ahead. As I mentioned uh, about the connections, the PLC will be the processing unit uh, of the measurements that are received through different sensors in the industrial facilities. So that would be the main method or the main kind of the main method of doing the computations of or processing of the data. So I think we'll be able to draw the network like this. So PLC will be the um, processing unit. To in this case, it will be like the embedded system. So programmable logic controller. It would be the programmable logic controller. So we can connect the uh, we can obtain, we can connect the PLC to different sensors. So we can connect to sensors which are there in the production lines, and also to the machines that are working in the production lines. And also we can connect them to the moving devices such as robots. So I will denote that using a circular device. So something circular in here could be like a circular robot which is moving on the floor. So if you have a moving robot, that also can be connected to the PLC system. So we can maybe consider that in here there's a wireless link. Using wireless links, the connection can be established between the robot and the PLC. Regard to the machines can be either wired connected or wireless connected to the PLC. Sensors also can be connected. So these sensors mean like temperature sensors, pressure sensors, some sensors which are required in the production lines. So any kind of quality monitoring sensors, air quality monitoring sensors, or moisture or humidity measurement sensors. All these sensors are type of sensors which can be connected to the PLC. So the data measurements that they make will be forwarded to the PLC, and using the PLC, whatever the algorithm that you include in here with related to the process that is happening in this environment, the PLC is able to convert the data into a useful format, which can be then forwarded to the next server that is collecting all the data regarding the environment in the industry. So local server will be collecting all the data related to the environmental this facility. So the local server will have the data. Apart from that, this also will be we can be connected to the router or the switch or the network component as well. So the PLC can be connected to the network router. So this could be the edge router that is there. So it would act as the gateway between the local network. So local network and the external network. So the PLC will be connected to the edge router as well. If required, it can directly send the data to the edge router, which will be connected to the internet basically. So internet, which consists of again like a collection of routers and switches. So it would be a like a wild combination of network components. So we will be sending the data to the internet. So one of these devices can be considered as the destination device or the destination router, and then the final destination point could be the server which is connected to this network device. So the destination could be the cloud server, and in there we can store all the necessary information regarding the industrial facility. So the edge router can also be connected to this local server as well through wired link or wireless link. So the local server, after making some decisions, it can also update that through the edge router to the internet and then to the destination. So likewise, we can have the connection to the internet and then to a remote cloud server through this network architecture. So apart from that, we can, I mean, this edge router we can call as gateway. Okay, so the gateway is something we call for a network component which connects the local network with an external network or wide area network, right? So the gateway connects two different networks together by considering the differences in the protocols of the networks. Connect two different network components, two different networks, such that those networks can communicate seamlessly, can communicate seamlessly. Connect two different networks using suitable protocols and methods. Connect two different networks that uh, use different protocols such that those can communicate seamlessly uh, without any problem actually. So the gateway will be like a component, network component that will connect to different networks using suitable protocol. So what I say here is that a network component that connects two different networks using a suitable protocol or protocols such that those two different networks can communicate uh, seamlessly and uh, efficiently. So I hope this is fine. If you have any questions, please let me know. So with the network architecture here, in the local server, we can do some computations at the local server. So local computing can be done in here. So in here, basically you can do edge computing. If you are doing some computing at the local server, you call that edge computing. And also you can do any kind of computing at the robot level as well. You can do some computing at the robot level as well, which we call as again edge computing. If we have a server at the edge of the network, which means at the local network area. The edge means the local area, local network area, the boundary of the local area network. We call as the edge. The boundary of the point in the local area network that connects with the external network. So the point of the local area network that connects with the external network. So the point where the edge and the other rest of the network connects, we call as edge. However, like in here, we can consider that all these devices which are in the local area network are also edge devices. At the edge of the network. If you consider the entire, wide area network, as a whole, this local area network that we have at one end of the network. So this part is at one end of the network, is in one corner of the network. Although we have this enlarged, this is one small edge of the network. So in this small kind of a point in the network, we have all these devices, which are edge router, edge computer, and then robots. So these are like devices which can do some computation. So those devices are known as edge devices, and they can do edge computing. So the term edge means that it is the point that connects the local network to the external wide area network. So if you consider the edge computing locations, it can be at the local server. Also, it can be at the robots. So another thing is that we also have something called the edge AI. We will talk about that in a later uh, uh, instance as well. So edge AI is something that we um, call when we apply some machine learning or AI method, AI model to um, to do some computation at the edge, edge computer, or yeah, edge at the edge of the network. If you apply an AI model to do some computations at the edge of the network, we call that edge AI. Edge AI technology is used. So if you use edge AI technology, that basically means that you are having a machine learning model stored in your local server, and that model is able to run machine learning algorithm and do the predictions. In there, actually, you don't need to run the AI model in a cloud server or in a fog server. You will be doing all that in this local computer. So this could be a laptop, this could be a robot, as I said, this could be another device which is at the edge that has the capability of doing the AI computations. So AI related work and do the necessary predictions from AI. So those are the devices that I mean there are some capable devices, and those devices are the devices that can do this edge AI process. Any questions up to that point? So one thing is that with this industrial IIoT systems, right? One thing that we need to know and we need to emphasize always is that with these IIoT systems, we enable connectivity more than anything, right? So connectivity is the special feature of industrial IIoT systems with the conventional industrial systems. So if I take the connectivity feature, you can observe connectivity in multiple places. If I going to draw that, connectivity should be available even between two different sensors or devices. Sensors in here and machines in here should be able to communicate with each other as well. Not only connect with the PLC, sensors are also communicating and connected to the other devices around them as well. Machines can communicate with the robots, and robots can communicate with the machines. So likewise, every device are able to communicate with the other device in this network. Okay, so that functionality is available with IIoT systems. So with the IIoT systems, the most important thing that you need to remember is that it has this connectivity feature included in that. So if somebody asks you what is the specialty in the IIoT systems and other conventional industrial systems, you must be able to say this word. Connectivity is enabled in the IIoT systems such that communication between different sensors to other machines, I mean, direct communication between sensors to machines and sensors to robots. I mean that basically means that connectivity between different IoT devices are enabled, right? Direct communication between different devices are enabled, and also uh, communication between the devices and the internet is enabled, right? So direct communication between different sensors. Direct communication between different sensors. We can call these different IoT devices is possible. And then connectivity between the devices, IoT devices, and the cloud or the internet is possible. So basically, it has internet connectivity. Third thing would be that it has the ability to do connectivity or connection between infrastructure to infrastructure, infrastructure to infrastructure connectivity. So what do we mean by infrastructure to infrastructure connectivity? So the infrastructure, what I mean is this one facility where you have this one manufacturing factory. There's a factory in here, right? So that one we call as the infrastructure. So if we call this as the first infrastructure facility, so the infrastructure one, which is basically the manufacturing facility one. So manufacturing facility one, if this is the manufacturing facility one, which is located in Colombo, let's say this is the factory which is located in Colombo, you can also have another factory which is in Hatton, let's say. There's another facility which is in Hatton. So because of this technology, we can also communicate with this infrastructure in the other place in Hatton. So there could be another industrial facility inside Hatton also, which is similar to this. So the same infrastructure that we have in Colombo facility can be inside this Hatton facility. Okay, so in Hatton also we have a infrastructure. So with this in connectivity, which is possible with the industrial IoT, we can do the communication between infrastructure in Colombo and infrastructure in Hatton. Likewise, we can have communication between different infrastructures, um, and we can communicate the data. So, any questions? So those are the things related to the IIoT features. So the main feature is the connectivity feature, right? So the direct communication between different IoT devices is possible. Then the communication between devices and the internet is possible. Basically, which is something that is available with any IoT system, which is basically having the internet connectivity. And thirdly, infrastructure to infrastructure connectivity is also possible, which enable this manufacturing facility to communicate with another infrastructure directly without any difficulty through the internet. So that the efficiency of the communication and efficiency of the production also can be increased. So those are the things related to IoT features. And then also you have to also know something related to the industrial standards that are related to industrial revolution, and then how we came into this era where we started using IoT in the industries. So I discussed this in the lateral entry class already. So I will just also mention to you also in here. I think in the last class you did not come to the lateral entry class, which I had from 8 to 10. So basically in there, I think I discussed about some related work on industrial standards. So yeah, uh, industrial standards have been defined, such as industrial 0.0, industrial 1.0. Likewise, there are different standards which are defined. So like industrial 0.0, the industrial 1.0, then industrial 2.0. Four point zero. And industrial 5.0 also is like proposed, but it is still under implementation. So when we are talking about the IoT based industrial standards have been defined in this industrial 4.0. So in this industrial 4.0, the integration of IoT with industrial systems has been commenced. Okay, so because of those things, we are going to discuss about the industrial 4.0 more than other standards. So the integration of IoT for the industrial scenarios has been done in this industrial 4.0 standard. So integration of IoT into the industry has been initiated or commenced in this standard. So the industrial like 0.0 is the first stage where the industries were like first introduced into the world. So this has happened with the 14th, 15th century, where the first industrial, printing presses were introduced. So this is regarding some history regarding the evolution of industry over the years. So how industry developed its performance over the years. So the first thing that has happened in the history is what we are going to talk about here. Okay, so this is like a small history section. However, like this is also kind of like an interesting thing to know about, and also this gives us what is the reason for the integration of IoT into the industry. The first industrial facility was the printing press, uh, which was introduced by a engineer called Johannes Gutenberg. So this engineer has implemented this printing press, and that is the first place where it had been initiated, where the industrial concept of industry has been initiated. And then the steam engine and the mass production has happened during the industrial 2.0 standard. So this is about, we are talking about 17th century. So first thing has happened in the 14th and 15th centuries. So in the industry 1.0, steam engine and mass production has happened and it has been happened in 17th century. After that, we have this Industry 2.0, where the electricity and steel manufacturing has commenced. So in here, we have this happened in the about the 18th and up to about 19th century. So 18th, we'll say this has initiated in 18th century. Basically, the usage of electricity. Then we have this the Industrial 3.0 system or the standard, where we have the next generation, which is basically usage of computer systems in the industry. So with this kind of thing, we were able to do that. I mean, this has happened in 19th century. So these computer systems actually enabled us to automate the tasks in the industry. So automated tasks in the industry was possible. So this actually, I think, came up. So all these, standards like Industry 1.0, Industry 2.0, they led to this to this next, eras of industrial revolution, where in Industry 3.0, we have the computer system that can automate different tasks. Then in 4.0, we were able to, collaborate IoT into the industry, such that we can improve the connectivity between devices in the industry. So in here, basically, connectivity is something that we are adding to the industrial facility more than the previous revolution. So in the first revolution, we had the steam engine. Second one, we had the electricity, and electricity made all these machines work, and electricity-based industrial systems were introduced. And then we had computer-enabled systems, which can, automate different tasks and do multiple tasks at the same time. And then now we have the integration of IoT into the industry that enables the industry to have connectivity features at every point in the manufacturing facility, such that we can generate a lot of data regarding the industrial facility. So this data is really important for us to monitor the condition of the environment and also get some ideas about what is going to happen in the next time instance. So that is the era that we are currently in. So Industry 5.0 is about basically going ahead of Industry 4.0, and proposing some intelligent systems, proposing in the cognitive technologies into the industry. So cognitive technologies means that technologies that enable human machine communications, human and machine communications, such that these you know uh, communications are able uh, between the machines and the humans in a flexible and a friendly manner. So human machine communications can be enabled, and for this we can use different technologies such as AI, cybersecurity, and so on. Cyber physical systems, all these technologies can be used. The trending technologies can be used for this uh, this task. So these are the evolutions. This is the way that the evolution has happened in the industry, and the different standards that are defined in the industry are as like this. So in there also, currently we are in the implementation of the Industry 4.0. So we are integrating IoT into the industry as much as possible, so that the manufacturing facilities are able to remotely monitor the facility, and also can generate a lot of data regarding the facility, which is very important for them. So in here, one thing is that this, this industrial facilities can be monitored by any remote user who's accessing the system, who's accessing the cloud server as well. If there's any remote user who could be the manager or the CEO of the company, can access the cloud server and can access all the data related to certain infrastructure as well. So the manager has the login information, Then using those information, he can monitor the date of the infrastructure in a remote location. So he could be in USA. He could be the owner of this infrastructure. He doesn't need to come to the infrastructure. He can remotely monitor each and every parameter regarding the infrastructure and even give his feedback regarding the process. So that is the kind of the importance of these IIoT enabled systems, so that you don't have to really, go and look at every process happening in the infrastructure, but rather you can stay in your own office and do the monitoring in your own comfortable space. Right. So we will be, discussing about further things regarding that. Maybe in today's evening, if you are able to join, I will discuss about the rest of this session in today's evening from 8 to 10. So I hope you will join. If you can join, please join. Otherwise, it will be hard for me to communicate that information to you. And there will be an exam question from this industrial IIoT section. So because of that, I think that you should have a good understanding and good knowledge about that. So I think with that, I would like to, conclude today's session. I will continue from the next, uh, time slot, which is today from 8 to 10. And then there I will explain about the rest of the discussion on IIoT, where I will be discussing about the key enabling technologies of IIoT. And then I will try to conclude this section. So I would like you to mark your attendance. So please, give your attendance if possible. Any questions? If you don't have any questions, I would like to conclude the session for today. So thank you so much for joining.